if you're here.
Yes, I am here.
Yeah. Safa is here. Safa, are you with us? Sorry.
Hello?
She's not here, is she?
I am here, sir.
Safa is here.
Safa Saad, yeah, you're right.
Yeah.
Safa,
He is here.
we're waiting for you to share your screen, if you don't mind, please.
Okay, thank you very much.
I think Seja just joined us. And, but yeah,
Oh,
she
Safa is already here.
Yeah.
Okay.
Seja, you will present after Safa.
Yeah. Safa, please unmute yourself.
Okay.
And Safa will be talking to us about the effect of adding graphene nanoparticles on the thermal performance of lithium, cobalt, nickel oxides cathode materials for lithium-ion batteries. Safa, please unmute yourself and on you go.
Okay, thank you very much. Good afternoon, sir. My research is titled The Effect of Adding Graphene Nanoparticles on the Thermal Performance of LCNO Cathode Material for Lithium-Ion Batteries by صفاء الساعدي, اسامة, ناجي, عدوية, حيدر. Presenter صفاء الساعدي. In the present work, the effect of graphene adding on the performance of layered LCNO cathode materials were investigated. Cathode material was prepared using self-propagating combustion method. The graphene was added to the prepared compound with different weight percentage, 0, 0.5, 2, 4, and 6%. For the purpose of improving cathode performance, the effect of graphene weight percent on the LCNOG mass loss was studied. Using the TGA, it was concluded that all the percent additive of graphene behave the same at all the temperature except for 6% added graphene, where at high temperature it has an inverse behavior. The development of rechargeable batteries for the powering of portable electronic devices such as mobile, laptop, and electrical cars. Battery safety is studied in terms of its temperature resistance, which means temperature that needed for the thermal runaway process starts. One of ways to prevent ways to reaction from ending in an explosion or fire is using components with more thermal stable. Graphene for the unique properties what it owns, like the large surface area in comparison with mass ratio, very high conductivity and high chemical stability. The main objective of the present work focuses on improving the cathode performance, thermal, magnetic, and electrical by adding graphene with different weighting percent to our compound. The experimental to prepare our materials, we doing the firstly lithium nitrate, cobalt nitrate, nickel nitrate, and citric acid were dissolved by deionized water, then put it on magnetic stirring device for 50 minutes with 25 centigrade. After that, we heated the mixture by hot plate for 30 minutes with temperature 100 centigrade. At last, we put the mixture in the furnace under 400 centigrade temperature for 50 minutes for burn the fully reacted reaction materials. Secondary, adding graphene with different weight percent, 0, 0.5, 2, 4, and 6%. characterization, we use the XRD, FESEM, EDX, AFM, and thermal analysis. Then we annealing at temperature 650, 750, and 850 centigrade. From the curve, we can show the loss mass located in three regions. First one, the percent of mass loss at 100 centigrade with endothermic. Second point, located at about 541 centigrade with exothermic peak. And the last one, the LCNOG pure phase formatted at 7 centigrade. From the histogram, we can show the minimum mass loss for the additive graphene weight percent at different temperature was 4%. This image for battery for X-ray pattern result before annealing with different additive graphene weight percent and show the materials have a hexagonal structure. All the materials are pure and single phase, and the predominant structure is polycrystalline oriented more intensity at 104 indices. And this figure is after annealing in different temperature and show increased intensity peak with little shift toward left, sorry, to left toward right. This is C for the same figure, and from the EDS was measured after annealing at different temperature, and its benefit is knowing the purity and the percent each element of composite materials. From FESEM image for LCNOG with 4 graphene weight percent at different annealing temperature, we can show that the particle size increase with increasing annealing temperature, with the average of particle size is 26 and 34 to 54. From AFM image for our compound LCNOG with 4 graphene weight percent at different annealing temperature, we can show the surface roughnesses was increased with increasing annealing temperature. The conclusion, the first one, the addition of graphene to the LCNO reduces mass loss because its sheets act such as filler reinforcing particles which attract the mixture compound. Second, there are critical adding percent of graphene at 6% lead to increasing mass loss at high temperature occurs due to the reinforcing effect of graphene reduces mixture components segmental mobility. And last one, it was found that the suitable graphene adding is 4%, which has high thermal stability and low mass loss and the annealing temperature of 750 centigrade. Thank you so much for your listening.
Thank you very much for that, Safa. Really appreciate it. Any questions from the audience? Please write them in the chat box. Safa, I was wondering, have you ever thought about doing Raman spectroscopy on your films?
Sorry.
Do you think Raman spectroscopy would be useful for your measurements?
Raman scattering, you mean Raman scattering?
Spectroscopy, Raman.
Yeah, I'm do it, but I don't put it in the present work.
Okay, right, okay. And the other question is what are the advantages of having graphene, basically, with these materials? What does graphene give?
Since graphene is a single atomic layer of carbon, so the lithium ions can be put between two layers of graphene, which mean storage of more lithium ions and increase the battery's capacity. That mean the life of batteries with graphene can essentially be longer than that for the conventional batteries.
I see. Another question from Asma or Asama. Can the researcher tell us why the lithium peak didn't appear in EDX?
In EDX, you mean?
Yeah, why did we not see the lithium peak in EDX?
There is no peak appear for lithium ion because it's the X-ray of lithium is ultra soft, about 50 electron volt or 55. So it present a great challenge to detect it.
That's true. That's exactly right. It's because the energy of lithium is very low and it cannot be detected by conventional EDX detectors.
Yeah, exactly.
Thank you very much for that, Safa. Really appreciate it.
Thank you very much. Thank you.
Thank you. Bye-bye.
Bye-bye.